Good morning, algebra. Sorry I can't be with you today, sorry I forgot to tell you yesterday I'd be gone, and but I just have an appointment to be somewhere, so I will be back tomorrow, hopefully. Well, for sure, and we'll take questions over Wednesday's homework tomorrow if you have any, and also take questions over today's homework if you have any. So if you're not ready to turn in Wednesday's homework that's due today, don't worry about it. Just turn that in tomorrow, and it'll all be good. So today, hopefully you picked up the note sheet. You should have that before you start. If you don't have the note sheet yet, push pause, go get the note sheet, and we can work through these problems for our new lesson. So we're going to solve equations with variables on both sides. Okay, so this is just the math language definition of what we're doing. We're using the addition and or subtraction property of equality, so we're just adding or subtracting to write an equivalent equation with the variables all on one side. So we're just going to rewrite this so that we don't have variables on both sides of the equation. We want our variables all to be on one side. So I'm going to subtract 2x and get it away from this 1. 3x minus 2x is 1x, and that is it. 1x equals 1. So that's all we have to do today. The equations are going to get a little more complex than this, though. All right. 3x equals 2x minus 2. So subtract 2x. Get all the variables to one side. That would be x equals negative 2. Don't forget that this minus symbol here goes with the 2. Here we've got 7y equals 5y plus 4, so subtract 5y. 7y minus 5y is 2y, and then 2y equals 4. Divide by 2, so y is 2. Okay, now they're getting a little more complex equations. We've got variables now on both sides, and we've got constants on both sides. So at this point, I've got a choice. I can choose what to do for my first move, and I'm always my preference is always to start with the variable term. Some people like to start with constants. It doesn't matter. I'm just always going to start with the variable term. So my choice is I can subtract 3x from this side, or I could add x to this side. Either one of them will get me there if I do the math correctly, but this way, to me, seems easier. If I add x, that leaves me with a positive variable term. So 3x plus x is 4x minus 2 equals 6. So here I want to add 2. So now I have 4x equals 8, and when I divide by 4, x equals 2. All right. Next equation, same thing here. I have a choice of what I could do. I could either subtract 5w or I could subtract 1w. Subtracting 5w would make this term negative over here, which I don't care for, so I'm going to choose to subtract w. 5w minus w would be 4w plus 15 equals negative 49. Oops, that's not a 9. Negative 49. And then now I want to subtract 15. So 4w equals negative 64. Last step would be divide by 4. So those 4's cancel out, and I have w left. And negative 64 divided by 4 would be negative 16. So that's it. Okay, next screen here. Decimals don't change the steps that we take. We still do the exact same steps. We just have to deal with some decimals. So in this case, I can choose to add 3.7x, or I could choose to subtract 10.3x. I'm going to choose to add 3.7x. So that would be 3 equals 14x plus 10. And then I want to subtract 10. 3 minus 10 is negative 7 equals 14x. And the last step would be divide by 14. So negative 1/2 equals x. Okay. Same steps with fractions. I know you guys love fractions, but not a big deal. Just, in fact, you guys get to use calculators. So really, I don't even want to hear complaining about fractions. So I could choose to either subtract 2/5 y or subtract 3/4 y. 2/5 is the smaller fraction, and if I subtract from 3/4, it's going to leave me with a positive fraction. I'd rather have a positive fraction than a negative fraction. So subtract 2/5. Oops, 2/5 y. I guess we should be proper here. And in these calculators, you can use fractions. Down in the bottom left corner, there's the ABC button. So I just put in 3 ABC 4 minus 2 ABC 5. And that tells me 7/20. So I have negative 8 equals 20 plus 7/20 y. Okay. Now I want to do something here to get that away from the variable. So minus 20 and 8. Negative 8 minus 20 would be negative 28 equals 7/20 y. All right. Now, we talked a little bit about this yesterday, but when you have a fraction in front of your variable, all you have to do to solve that is flip it and multiply. Some people say divide by the number in front of the variable. That's fine, but when you divide by a fraction, you really have to flip it and multiply. So it's the same step. I'm just skipping the division part and going straight to the multiply. 20 over 7. And so these fractions cancel each other out, which leaves me with y here. And then to multiply a whole number times a fraction, you don't even have to use a fraction button. I'm just going to multiply 28 times 20, divide by 7. And I can do that all on the calculator. So 28 times 20, divide by 7 is 80. And then I see that I have a negative times a positive. So it's negative 80 for my solution. Okay. On to some word problems. Personal trainer charges a one-time fee of $60 plus $25 for each individual session. A new fitness club charges a yearly fee of $450 plus $10 for each session with a personal trainer. Write and solve an equation to determine for what number of sessions will the cost be equal. Okay, so we just are going to write two simple expressions, and then we're going to set those expressions equal to each other to find out when that number of sessions is equal. So $60 plus $25 for each session would be 60 plus $25 times the number of sessions. Use whatever variable you want there. Then a new fitness club charges a yearly fee of $450 plus. So this is the part for the fitness club, $450 plus $10 for each session. And the only thing here is I have to use the same variable. If I don't use the same variable, then that makes it an impossible equation for me to solve. But since we set them both with the same variable, just put an equal sign between those two expressions, and now we can solve the equation with no difficulty. So I have a choice here. I can either subtract 10x or I can subtract 25x. So subtract 10x. I have 60 plus 15x equals 450. 25x minus 10x is 15, so it's because that's positive, you leave it as a plus. Now I can subtract 60. 15x equals 390, and then divide by 15. So 390 divided by 15 is 26. X equals 26. And so what that means is if you're going to do 26 sessions a year, 26 times with a trainer, then it doesn't matter which plan you choose. You're going to pay the same amount of money. But if I only want to go once a month, so I'm only going to do 12 plans a year with a trainer, then this one is going to be a lot cheaper. But if I want to do 52 plans with a trainer, do it every week, then this one's going to be cheaper. So that's the use of these type of expressions, or being able to do these, is you can compare the values of two different things. All right. Now, same thing here. We're just solving equations with variables on both sides, but we're going to get into things where we have to use distributive property. We might have to simplify things on one side before we make our steps to solve the equation. So these are going to take more steps, but you know how to do all the steps, so it's not too big a deal. Okay, so first thing I want to do here is notice I need to simplify all this. I can't start solving it until I have all these parentheses done away with and get rid of these extra terms here. So I'm not going to do anything to the left side yet. I'm just going to rewrite it. 5x plus 5 equals, now I'm going to distribute. So 3 times 5x would be 15x. And then distribute here. So 3 times minus 4 would be minus 12. And this is outside the parentheses, so it doesn't get multiplied by anything. It just is still there, minus 10x. Okay, I'm still not ready to start solving yet. I still need to simplify this side. So 5x plus 5 doesn't change. And then I've got 15x minus 10x. I can combine those two like terms. I can simplify this. So 15x minus 10x is 5x minus 12. And now I can start the process of solving. So I can do 5x minus 5x and minus 5x. So those go away, and I have 5 left here. And those go away, and I have negative 12 here. So 5 equals negative 12. I'm not okay with that. So this equation is broken. It is a no solution equation. The temptation for some students here at this point is to start making all of these equations no solution because they look tricky and they look hard and it looks like a lot of steps. So I'm just gonna kind of dance around some numbers up here, and then I'm gonna write no solution at the bottom. Most of them will have solutions. Every now and then they throw in a no solution one to see if you're paying attention and really know what you're doing. But these are going to be rare. It's going to be more common that you have a solution. All right, this one looks scary, but anytime you have, these are called nested parentheses. I have one set of parentheses nested inside another set. You always start as far inside these nested parentheses as you can and work your way to the outside. So this one is going to take us several steps of simplifying before we can start the process of solving. So 5 times 2x minus, and now I'm going to have to distribute this. So minus 4 times x would be minus 4x, and then a minus 4 times a plus 5 would be a minus 20. Okay, so then I need to simplify what's inside the parentheses. So I have 5 times 2x minus 4x would be negative 2x minus 20 equals 25. Okay, now I can distribute the 5. So I've got another layer of multiplication here to do. 5 times negative 2x would be negative 10x. And then 5 times minus 20 would be minus 100 equals 25. Okay, add 100. So negative 10x equals 125. And we can do just divide by negative 10 here. So x equals negative 12.5 or 12.5. Either way is fine. Okay. Just double checking all my math here, make sure I didn't make a mistake. I don't think I did. So that one does come out with a decimal. That's fine. Last one here. Once again, got several steps in order to do before we can start the process of solving. So I'm going to distribute 3 here. So 3 times 2b is 6b minus 3 times 1 is 3. And then still have minus 7 here. And that equals 6b minus 10. So simplify this side. And this is a step that I noticed a few people were struggling with on past assignments and on, I think maybe on our test. When you have a negative symbol here and then a minus 3, we have to treat this as negative 3 minus 7. And some people were doing 3 minus 7 and then not seeing this negative sign here. But treat this as negative 3 minus 7. So it would be 6b minus 10. Negative 3 minus 7 is a negative 10. Okay, and then we have 6b minus 10. You see where this one's going. So subtract 6b. You end up with negative 10 equals negative 10. So this one is an infinite solutions. Okay, and that is that. So your assignment today, and I know some of you are not liking the assessments, the website, and I did not put this one on assessments today. It's not in Google Classroom. It's just right here. This is the only place you'll see it. So pages 100, 101, do 10 through 40 even, and just do those on paper, and we'll collect those papers up on Friday. Hope you guys have a great day, and I'll see you tomorrow.